All right, here we go. It's been a while since we had a video, huh? So let's get this one going. Why don't you take a minute, read this over, read this problem over. Okay, go ahead and pause it up and do that. All right, so part A says to find the overall average number of study hours per credit hour for each student. So study hours per credit hour. Study hours per credit hour for each student. So I'm going to go with Ben first. Ben did 21 to 12. Okay. So how do I know that it's like that? Because it said per credit hour. Whatever comes after the per is going to be in your denominator. Whatever comes before the per is going to be in your numerator. So if I were to reduce that 21 divided by 12, I get 1.75. That's study hours per credit hour. All right, Kate was 19 over 16. You're gonna have to forgive me. I got this stylus and I forgot my regular one, so I got a little one today. Got a battle. 1 point. You could say 1.875 is what I got. I'll round that to 1.19. Okay. Are they meeting the college rule of thumb? The college rule of thumb says spending 2 hours outside. So technically, no, they are not. But realistically, whatever works for you. All right, next one. Find the hours studied per credit hour for each course Ben takes. Average the 4 rates. Does this match Ben's overall in part A? Why would I not repeat this process for Kate? So what I'm going to do is I'm going to divide each. I'm going to go total hours divided by credit hours. I'll go 6 divided by 3, 6 divided, and so on and so forth, and fill it in. So 6 divided by 3 is 2 for history. 6 divided by 3 is 2 for statistics. 4 divided by 3, I got 1.33 or 1.3 repeating. And then 5 divided by 3, I get 1.67. Again, this is just another way to find what we found in part A. And then for my average, remember average, I'll add all 4 of those numbers up and divide by 4. And I get, 1.75. All right, why don't you go ahead and repeat that process for. So the question asked, does this result match Ben's overall progress or overall average in part A? Well, Ben was 1.75 here and 1.75 there. So yes, it does for Ben. 1.25 for Kate and 1.19 for Kate, and no, it does not for Kate. So why might this be? Well, first of all, I would look at their credit hours. If you look at Ben's credit hours, all of his classes are 3. Kate's varying. Okay, it's varying, and that's very important. Okay, that's very important. So, like the number of credit hours affects their average. And I'm sorry about my handwriting here. I would say the best way to explain that would be the number of credit hours is different. Okay. So our discovery question. So what we're going to ask is, can you recognize when to calculate the weighted mean, and how is the median of a data set different from its mean? Okay. So let's talk about the weighted mean. We're going to do this at the end of class to calculate GPA. All right. This is what happens when you're calculating your GPA. You're calculating a weighted mean. Okay. Because and as well as in our class, when you think about your overall grade in the class, each category is weighted differently. Okay. So how do I calculate the weighted mean? Well, what I want to do is take my first value times with the quote unquote weight that it carries. Second value times that weight. Third value times that weight, and so on and so forth. And then add up all and divide by all the weights added up. So it's hard to explain that in words, so the best way to do it is to explain it with a problem. Okay. Find the weighted mean of 15, 25, 100, and 250 if 15 carries 4 times as weight as the other values. So 15 carries 4 times the weight as each of these other three. So 15 times 4, since it's 4 times the weight, plus 25 times 1 plus 100 times 1 plus 250 times 1, all over 4 plus 1 plus 1 plus 1. Okay? Could I have put this as 8? Yes, if I did this as 8, then this would be 2, 2, and 2. That's fine. I think the easiest way to do it, though, is to use 4 and 1. All right, so 4 times as much weight as the other values. Okay, so I'm going to pause here and I'm going to calculate that. I got 435 on top and then 7 on the bottom, and that becomes 62. It's 62.14. And that's fine. Okay, 2 decimal places. It's 142. So let's keep going. All right, let's look at an example. Now the book does the work for you already. So we're just going to talk through it. This is what happens when your grades are calculated in this class. PowerSchool does it for me, but I could do this by hand, or you could do it by hand if you want to explore, how a test will affect your grade. So if students' points are, here's their average, okay? Homework, they have a 94, quizzes 87, midterm 66, final exam 63. All right, this is how their grade is calculated by category, okay? So what would I do to, solve this? If you want to read it, go ahead and read it, so pause it. All right, so category, grade is 94. For homework, the weight was 10%, and how do I write 10% as a decimal? I move decimal place over twice, okay? So what I need to do is what they're doing 94.4 times 10. Times 0.1, times 0.1, times, okay? I'm multiplying straight across, and then my sum is 69.79. All right, so that's that student's grade in the class. The teacher rounds an additional number, the grade is a 70. Okay, if this teacher does not round, the grade is still a D. If the student assumed each category or the category percentages could simply be average, he would have incorrectly thought that he had a 77 in the class. Okay, so that's a common mistake people can make. If they just take the average of these grades, 94, 87, 66, and 63, you would have gotten a 77 in the class, and that would have been a lot better than what he actually had. All right. So, yeah. All right. That probably doesn't make much sense, but don't you worry. At the end of class, we are going to do an example together, okay, to help out with this a little bit more. Again, this is just how to find the weight and mean, okay? This gives you a nice little example here if you want to look that over. All right. 20 employees earn $18.75 per hour, 5 earn $22 an hour, 100 earn $9 an hour. So $18.75 is being multiplied by 20 because that's the weight that it carries. 22 is being multiplied by 5 because there are 5 employees that have it, or they earn that amount per hour, so that's the weight that 22 carries. Same thing, 9 times 100, since there are 100 employees, and I add up all the weights, okay? Then you get your average. All right, so the following data represents the years, the ages of years of cats at a shelter. Find the average age of cats instead of entering the values in your calculator separately. Use the frequencies to find the weighted mean. All right, so what I'm going to do here, I'm going to pause the video here, and I'm going to fill in all the ages and their frequencies, all right, so that you can copy that down. All right, so take a minute, take a look at this, all right, each of the ages and the frequencies. Okay, so this last column, all we're going to do is we're going to multiply our age times our frequency, like it says there at the top. So I'm multiplying straight across. 1 times 7 is 7. 2 times 3 is 6. 3 times 10 is 30. 16. 55. 12. 8. 11. 15. Okay, in the bottom here, I'm going to find the sum. So I'm going to find the sum of my frequency. Go ahead and pause that and go for it. All right, so I got 40 and 160. Okay, so what we want to do now is to find our weighted mean. Right, we want to find our weighted mean. We do this like literally. Why are we doing this? Right? Why use the weighted mean and not just the mean? This is gives us a little bit. It's a little bit easier to find, to use the weighted mean in this situation because when we're averaging, it makes our life easier. Instead of adding 1 plus 1 plus 1 plus 1 plus 1, 2 plus 2 plus 2 plus 3 plus 2 plus 3, and all of these numbers up, I can just do 3 times 10. I can just do 5 times 11. Okay, that makes your life so much easier when calculating an average. All right, so how do I know when to use the weighted mean when I'm looking at something like this? Okay, when there's a lot of different numbers repeating. All right, that helps me a lot. So if I want to find the average age, I would just do 160 divided by 40, which is just 4. All right, so our average age would be 4. Average age of cats is 4 years. Okay, next one here, we're going to talk about median and mode. All right, we've talked about mean. Obviously, we just finished talking about mean. That's our average. Median is the middle. Okay, median is the middle of a data set when it's arranged from least to greatest. Okay, mode is the most common value or values in a data set. All right, those are our two differences. Median is the middle. Mode is the most common. Find the mean and median for this data set. And we'll go from there. All right, so mean. First question I'm going to ask you though, should I use a weighted mean? No, there's not a lot of repetitions here. I can just add these straight across. 19 is the only one that appears twice, so I can add these straight across. So I'm going to go ahead and do that. 8, go ahead and pause and do that. I add those all up and divided by 8 since there's 8 ages, and I got 20.5. All right, the median, which is the middle, all right, so I need to arrange this so it's from least to greatest. So let's do that. Okay, so I'm going to add 17. I go ahead and pause. Okay, so how would I do this? This is how I think of it after I arrange it. I just go right here. Boom, 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 boom. All right, so the median is in between 19 and 20, or the average of the two numbers. So I would do 19 plus 20 divided by 2 to get 19. Now I know that in the middle of two numbers, there's a half like that. That is obvious. Sometimes it might be, it could have been 19 and 24, and then I would actually have to find the average of 19 and 24 because that would be the middle. Okay. The part of that question said, if a student who is 55 years old joins the group, how would that affect each data measure? Well, obviously it's going to skew our data. Let's try it. So if I add an extra student, add a 55-year-old in this, okay? I want you to find the mean and the median. You do that. I'm going to show my process for the median. I keep crossing off on the high from low, high to low, high to low, or low to high. So my median age is 20. Does it affect it? Yeah, the addition of a 55-year-old increases our mean, increases our average. All right, and it doesn't really change the median much. It just goes up by a half, right? Which kind of makes sense. But it does affect the average because it is so much higher than our other numbers. All right, we are going to do this part as a class. Okay, so you can go ahead and pause and hop back on the class link at this point. We'll see you there.